The spring sunshine may finally be here, but some of us are still recovering from the wet and dull winter we've just had. It wasn't the record breaker many of us may have been expecting, but it was an exceptional winter in many ways. Welcome to this week's Deep Dive. I'm Annie Shuttleworth, Met Office meteorologist and presenter. And in this show, I'm joined by Mike Kendon later on, climate information scientist here at the Met Office. Now, we'll be taking a closer look, a deep dive into the winter stats, how it stacks up compared to previous winters and some of the major events that happened over this winter. Now, if you're new to the deep dives, make sure you subscribe, share this video with anyone you think might enjoy it, and don't forget to leave your comments. We do read them and we will be answering some of your questions in this week's live on Friday. Now, before Mike joins me, I'm going to go through a few of the details of what the weather pattern was through much of the winter that brought some of us a fairly exceptional winter. Now, here I have a chart put together by Dan Holly, Chief Meteorologist here at the Met Office. I'm going to explain it, but it essentially shows us the dominant wind directions throughout January and February as a whole, because our weather pattern was really stuck in a rut. So on the far left-hand side here, this is the average wind directions and strengths for January and February as a whole. This is the 1991 to 2020 average. Now, you don't need to look at the details too much, but it's generally just the pattern that we need to focus on here, that the wind direction usually comes from the southwest or west. You can see that focus of these circles more dominant in the southwesterly and westerly sectors of this circle. And the next circle I've got here in the middle shows the observed wind directions for 2026, January to February. The colours show you the date, so the paler blue are from the 1st of January, we go to dark blues all the way through to pink, which is late February. And the pattern is quite obviously very different to usual. It's worth saying that no one January, no one February really does fit that average setup. Obviously, every month, every year is different. You don't often get a completely spot-on average month. But those averages are useful when comparing data from over lots of years. Now, the main thing you can see here is that we've got this big section over in the southeasterly portion of this graph, showing that we had really dominant southeasterly winds for quite a long period of time. Now, southeasterly winds are a pretty unusual direction, especially during the winter, but especially for a long period of time. It's something that you only really see for a few days at a time. Now, the colours show that we had them from late January, that's the yellows, all the way through until the middle to late February. So that's a 3-week period where we had those southeasterlies dominating. And then this third graph shows you how basically the difference between these two, the anomaly of this year compared to average. And this is the you can see in the red here, we've got more than usual, those southeasterlies, as I said. There's also something here showing we had more northwesterlies as well, because we had that period of northwesterly winds, that cold spell in the early part of 2026, which you can see here, those light blues, those pale blues, showing us that in the first part, the first few weeks, we had that really cold spell that actually did bring some of us a pretty dry start to the year. So there was some sunshine, but for a lot of January and February, these southeasterly winds have dominated. Now, these dots are not just showing the wind direction, they're showing the different weather types. So this is using the Lamb-Jenkins weather types, and the data's from the Climatic Research Unit at the University of East Anglia. So it's much the same as the decider data you may have seen on deep dives before, characterising weather types into certain patterns. So they've looked on every single day and put them into those different characteristics, and that's what's indicating where those dots sit exactly. But southeasterly weather types have dominated through the bulk of winter, at least the latter part of winter, and that has meant that it has been an exceptional winter for some areas. Now, Mike Kendon joined me earlier on today to talk about more details about this winter. Mike, thank you so much for joining me today. You're a climate information scientist here at the Met Office, is that right?
Yes, that's right. So I work in a small team called the National Climate Information Centre, and we're responsible for monitoring the UK's climate.
And today we're going to be talking about the monitoring of the winter we've just experienced. Not the record breaker we were all expecting, or many people were expecting, but certainly an interesting one.
Yeah, absolutely. I mean, every winter is different, as we all know, and the winter just gone was no exception. And certainly it was a very unusual winter with some significant impacts in some areas.
Yeah, so today we're going to chat about what the setup was through the winter, some of the details of the stats, any records that were broken, and some of the big events as well. So let's get started and chat through what the pattern was, because it was a pretty repetitive pattern, wasn't it? Those that watch the deep dives regularly will remember us talking about the weather setup, and it didn't change a lot, did it, through winter?
Yeah, I think really, if we focus on thinking about the second part of the winter, so particularly January through to February, the weather seemed to get very much stuck in a rut. And this chart kind of illustrates this. So this is showing mean sea level pressure relative to what we'd normally expect, so anomalies across the North Atlantic. This is actually covering January, but February is likely to look extremely similar. And the bar at the bottom shows you whether we are above or below average mean sea level pressure. And so you can see for the UK, much of the UK is very, very dark blue. So we had a deep low pressure anomaly across the UK and to the south, and red to the north, high pressure anomaly up there. And that obviously related to the weather we experienced through that period.
So we had low pressure dominating, and it was slightly further south than usual, would you say? Or?
Yeah, so in particular, the weather we experience is obviously strongly influenced by what happens with the jet stream up in the upper atmosphere. So people may remember, in fact, we've still got it, some severe wintry weather across the United States with cold air moving very far south, some quite severe snow storms over there. And what that tends to lead to is an amplification of the jet stream, a more powerful jet stream, because it tends to be driven by a large temperature contrast. So if we have cold air moving south, we get a large temperature contrast in the US and a powerful jet stream, and the jet stream was further south than usual, affecting the UK.
Is that because the cold air was pushing further south across North America as well?
Yes. We have a slightly more southerly jet. That's obviously associated with these areas of low pressure coming towards the UK. But then we had a blocking high pressure over Scandinavia. So what happened is, as we get low pressure systems coming in, they tended to come up against that high and get stuck. Which is why we tended to see the weather very much in a rut, with the same areas getting very persistent rain through from early January all the way through much of February.
Yeah, I felt like we were just issuing warnings for the same places again and again, because the ground was just getting more and more saturated in those same areas. But and for some of us, it really did feel like the wettest winter. It felt like that, didn't it? It wasn't for the UK as a whole, but regionally, actually, if you look at things in more details for rainfall, there is a bit more to be said. I've got the rainfall anomaly maps here, which show the winter rainfall compared to average. Something we use, a good measure of rainfall.
Yes. So we use the period 1991-2020 as a standard 30-year period for averages for monitoring our climate. That 30-year period is following guidance by the World Meteorological Organization. So this map is showing across the UK spatially how much rain we've had relative to average. And you can see basically the key feature is that it's been very wet in a swathe from Cornwall through central England and eastern Scotland, and also the southeast of Northern Ireland. And in contrast, we've had quite dry weather across the north and west of Scotland. And that really links back to the previous chart that we were showing with the low pressure down here to the southwest of the UK, and really with we're actually often in a southeasterly flow, bringing in weather systems from a rather unusual direction.
Yeah.
And so these areas, kind of central England and to the east of Scotland and the east of Northern Ireland, have tended to see a lot of rain from fronts coming up, and hitting higher ground, causing what we describe as orographic enhancement of rainfall. So that's as the rainfall increases across high ground, which forms a barrier to the airflow and forces it to rise. So we've seen like these large temperature contrasts across Scotland. Just to give you an example of that, I think it's the first 9 days of February, Aberdeen on the coast saw 120 millimetres of rain, Aviemore saw only about 2 millimetres of rain. So that's a huge difference in a short distance, and it's basically because of the mountains in between taking out much of that rain.
And it's also kind of the opposite of what it usually is as well, in a way that you normally see our weather coming in from the west, don't you? Like we've said, the southeasterly winds were unusual because we normally see everything coming in from the west. So normally you get the same effect, but the other way round.
Yeah, it's normally the other way round. And what's interesting is, Western Scotland here is climatologically wet, but it's actually much drier than average. And in contrast elsewhere, where we seem to feel like we had relentless day after day of rain, some places in the west of Scotland had long periods that were actually dry. So there's a weather station on the coast in west of Ross, a place called Oiltby. I'm not entirely sure I'm pronouncing it correctly, but that recorded actually 21 days with no rain from late January through to mid-February. And this is an area where you would expect, in the normal winter, you'd expect,
especially at this time of year. Sometimes you get beautiful weather there in springtime usually, don't you? But it hasn't been for those areas the wet winter they were probably expecting.
No, I mean, I suppose what we've had is we've had persistence for a particular weather type instead of what we might more typically expect, which is a mixture of weather types associated with the normal variability that we experience in our climate.
Yeah, so it was particularly January into February when we started to see that, when we got stuck in a rut, as you said. Let's have a look at the breakdown for each month. So this is December. Doesn't look particularly notable. It was a wettish month for some areas, a dryish month for others, but
I mean, December's obviously a wet month normally, right? But this shows, by and large, over the UK overall, the rainfall is not especially unusual for the time of year.
Yeah, and then as we went into New Year, we had that quite nice weather actually at the beginning of the year, didn't we? It was cold and sunny, at least for a bit.
I can tell you it was bitterly cold at times. I went walking with my family on top of the Lake District Fells I think it was the start of January, and it was really cold up there. On the top of the fells, the day we were on the top, the air temperature was maybe -3. The wind speed was gusting perhaps 50 mile an hour.
Oh wow!
And
that's quite a wind chill.
It was cold, but it was dry. It was dry.
Yes, you could at least see you have good views, I imagine.
Yes, very nice. I mean, that's the benefit of when you're in a northerly airflow like that.
Yes.
You get nice, clear air, so lovely views. But we're very lucky because obviously after that, the weather got into this very unsettled pattern. And this map for January is really illustrating that, isn't it? With the dark blues being areas that have seen twice the normal rainfall.
Wow. Because we've got 200% as the darkest blue. If it's white, it's around the average, basically. But really highlighting the south coast in particular and the northeast, which is when we started to get the repetitive days of rain. We started talking about endless days of rain through the year, and also lack of sunshine as well.
Yes,
particularly for Aberdeenshire, wasn't it?
Yeah, we did. So we saw, some areas 30, if not as many as 35 consecutive days with a millimetre or more of rain, particularly, for example, across Cornwall. We just saw a relentless number of days where every day was wet, there's very little sunshine, and of course that really links to what the weather feels like. It just, you know, it feels pretty relentless when you don't get a break or a day or two when it's dry with a little bit of sunshine.
No, and then into February, there wasn't a huge amount of change. You've still got a similar pattern, but I guess it's spread up a little bit further into parts of the wetter weather in England.
So very wet, quite widely across central England. And I guess if we think about things like flood impacts, what's important there is to think about this rain is falling across, obviously, river catchments. If we have large river catchments, like, for example, the River Severn, then those catchments will take quite a long time to respond to rainfall. But when you get a large amount of rain over a large area, the ground is saturated, it really builds up, and you end up with a situation where you have flooding. And of course, once the ground is saturated and you get day after day after day of rain, you only need a little bit more rain to cause some quite significant further flood problems.
Yeah, something that usually wouldn't be an issue, you wouldn't put your ears up if you heard it. When you've got conditions like that, you think anything could tip this over the edge.
It's absolutely critical for hydrology, is what we describe as antecedent conditions.
Yeah.
So the conditions across the catchment prior to the rain arriving, and there may be situations where the same amount of rain, if the catchment is relatively dry, it has the capacity to absorb that. Whereas if the ground is completely saturated, the rivers are already running very, very high, that same amount of rain will just very easily cause flooding, you know, across the floodplain.
Yeah. And we did have a few events, didn't we, that did cause some major flooding that we'll talk about in a minute, some of the major storms. But before then, let's just show how that stands. So that's kind of how wet it was compared to average. But in terms of records, so how do we measure records, first of all?
Yeah, OK. So we're showing all these nice maps. So it's worth just mentioning that all of these maps are based on a data set called HAD-UK Grid, which the team I'm in, National Climate Information Centre, we maintain this data set. So this is 1 kilometre resolution gridded rainfall data for the UK. We grid temperature as well and sunshine as well. So daily rainfall, and essentially what we are doing is we are estimating rainfall totals in millimetres at every 1 kilometre grid point across the UK. By taking the observations from the network of rain gauges across the country. So the full network of rain gauges across the UK is about 2,000, although for maps that are produced in near real time, it is actually less than that, it's more like 1,000.
Okay.
But that gives us the ability to look at what's happening spatially across the UK. And this data set had UK Grid. We have records extending back to the 19th century. So obviously a key application of that is to use the climate series that we can obtain for that, things like national series for the UK or regional series. We can look at these to see, to understand what is the observational evidence for climate change in the UK in the context of those long-term records. So that's just to mention how we produce that,
where that's come from. And and we can compare years to years and exactly UK level records, but also regional records.
Yes, and I suppose the key thing is that we're comparing one year against another on a like-for-like basis, even though the network of rain gauges or weather stations might have changed over time, because we are interpolating the data onto a grid. What we will see in terms of statistics from that grid will be independent of any changes in the network on which it is based.
Okay, yes, so that's why you can compare years, it gives us more accuracy in that. So this shows us the rainfall amounts of the winter as a whole, but how that ranks in that league or in that series.
Yes, that's right.
And so we had a couple of counties that actually saw their wettest winter on record, didn't we?
Yes, we did, yes. I mean, so this is showing that the wettest is dark the darkest blue. The next blue is second to fifth wettest, and then we've got the next blue is 6th to 10th wettest, and I think after that we're into the wettest third of the series. So these series run back to 1836. I would say before about 1850, 1860, there's more uncertainty with these county level series because of the density of rain gauges that make up the network. Reduces going back in time. But this is certainly very useful for giving us an indication of how extreme the rainfall was. So we can see that for Cornwall, we had, I should also say this is provisional data because we will update these figures once we have the full network of rain gauges, the full network of data come in, which also needs to go through quality control as well. So that's something else I should mention.
Rigorous checks, aren't there? Which is important because we base such information on how our climate's changing on all of this data. So,
but I think the main thing I'd say is just trying to step back and look at this from a wider perspective. We can see a large swathe from the Midlands down to Cornwall has been very wet, and the wettest on record for Cornwall. But all of these county areas between, say, the 2nd and the 5th wettest on record, also very wet in counties in eastern Scotland, areas like Angus, for example, and also very wet in County Down in Northern Ireland. Again, that's reflecting the way we've had some quite persistent rainfall in that area, for example, particularly across the Mourne Mountains.
So it was the wettest for a few counties, and in the top 5 for quite a few areas as well, across parts of England in particular, and as well, some areas of Northern Ireland and Scotland. So for those that have felt like it's been the wettest winter, like it pretty much has been for some areas.
I think this is the limitations of a UK figure. Because obviously the weather we all experience is where we happen to be located. So if you actually were living on the Isle of Skye, you probably felt like you had a pretty, nice, dry, quite sunny winter. Whereas if you're down in Cornwall, it's felt extremely wet and very relentless. And actually, what's interesting is that northwest to southeast contrast in rainfall patterns that we've seen this winter in the UK is a pattern that is quite commonly, you do quite commonly see that. And this really relates to the spatial scale of the UK and how it is affected by small changes in the position of weather systems and
jet stream, the wind direction. We're an island affected in all different directions, and each direction brings something different. Usually it's from the west, but this winter it's from the south and east. We've got as well, which from what you were saying, it really depends on where you are as to how you feel. So the wettest winter on record was 2014 for the UK, as a whole, but was that the wettest winter? For how many regions was that the wettest winter?
It's a great question, isn't it? So hopefully this graphic is trying to get that point across. So the colours here are referring to the year of the wettest winter across different parts of the UK. So I'm not very good at describing colours. This sort of lightish brown colour down here.
Orangey, I'd say, that one,
orangey, and up here. That is winter 2014. So that is December 2013 to February 2014. And people might remember that winter where we had really a relentless succession of deep low pressure systems every few days, one after the other coming in, and caused some really severe flooding, for example, in the southwest across the Somerset levels and more widely. And that's the wettest winter on record for the UK. That's actually before we started naming storms. We started naming storms in 2015.
So I wonder how many there would have been.
There would have been a lot of named storms for that winter. So that's the wettest winter down here and up here. And let's say this. Our series goes back to, the winter series goes back to 1837. So that is really a long-term context. If we look at the darker brown, I guess that's darker brown in northern England.
Terracotta?
Yeah, that's terracotta. That's 2016. So that's from December 2015 to February 2016. And again, people in Cumbria might remember the very severe flooding from Storm Desmond in December 2015, where we saw there's a rain gauge at Honister Pass which recorded 340 millimetres of rain within a 24-hour period. We actually had a record set for the UK of the wettest consecutive 2 days on record, over 400 millimetres. So huge amounts of rain. Very severe flooding, for example, in parts of Cumbria from that winter. But what's interesting is, these winters, they cover fairly substantial areas. So winter 2014's here, winter 2016's up here. So there is some spatial kind of coherence in this map, in that, it's not lots and lots of individual colours.
No.
As you perhaps expect. For several adjacent counties, the same winter is the wettest winter on record.
Yes, because I guess it's, and as you've mentioned, it's kind of key events that often bring, like for Storm Desmond, for example. Without that, we wouldn't maybe have had we wouldn't have had as much rainfall, but it's those that sort of topple things over the edge to make them more exceptional and a record breaker. And we have had some major events, or some notable events, certainly this winter.
Yeah,
we've had
absolutely.
A few named storms. I've got some bits of just some of the key things from the winter. So we'll talk about the storms first of all that we've had, as we were talking about those. So this is the storm naming list to date, how far through we've got them. We have been affected by a few. Obviously, it's been a very busy storm season for sort of Iberia in particular.
Well, again, that goes back to talking about the jet being slightly further south, of course.
Yeah, and sea surface temperatures being higher than average as well across those areas, so more moisture in those storm systems as well. So they've had some exceptional rainfall. But we've had 1, 2, 3, 4, 5, 6 named storms affect the UK. Not all of them really notable ones, but from this winter, so we've got Storm Claudia was the first one. That was not quite from the winter, that was still in November, but that kind of set the scene for the wet weather across South Wales in particular, didn't it?
Yes, and sorry, which is Storm Goretti?
Storm Claudia, that one.
Storm Claudia, oh yes, sorry, I beg your pardon. Yes, so Storm Claudia, yes, it was very wet around then, and we kind of also we were having some very, very wet weather in late autumn.
Yeah.
Claudia in particular caused some quite severe flooding around Monmouth in South Wales.
Yes.
Actually, from this storm, we saw basically a front stalling across England and eastern Wales, and kind of a slightly southeasterly flow, and the upland areas in southeast Wales, particularly the Black Mountains, saw a lot of rain, and that came on top of what was already a very wet period, and so that, as I say, that saw some quite bad flooding in Monmouth.
Yeah, so that shows that we were already in quite a wet period from the autumn, weren't we? And then through December, we had Bram affecting more northwesterly areas, I think it was.
Yes, it did, yes.
But that wasn't, it was a storm, so it's very impactful weather, but nothing extremely notable. And then the next 2 storms that came in affected that similar southwesterly area, notably Goretti in the new year.
Yes.
Which was a rare red warning we issued for Goretti.
Yes. I mean, prior to that, we obviously had some drier weather briefly around Christmas to New Year, which was maybe an opportunity for things to dry out a bit before we then got into this relentless cycle of low pressure systems,
of course.
Really, of which Goretti was pretty much at the start of that. As you say, a red warning issued for Cornwall and the Isles of Scilly, and I think it's always important to emphasise just how important this is as a tool, storm naming and these warnings for communicating the hazard to the public. And I'd certainly like to think that the number of fatalities that happen as a result of storms like this are much less as a result of these warnings issued, because people are not, they're not out and about if they take action and heed these warnings.
Yeah.
Actually naming the storms is really integral part of that.
Yeah, it gives us more consistency in delivering a message to the public. One of the key advances of naming storms. So Goretti brought the 99 miles per hour at Scilly. I think it's the strongest gusts in 47 years.
47 years, yes. And obviously that we saw some, large trees coming down from that.
Yes.
If you think about pictures in the media, for example, of St Michael's Mount. And some very strong wind gusts here. In many ways, this storm was quite similar to Storm Ciarán back in November 2023, which also affected the south coast of England. And I think what these storms really illustrate is that, we are in the firing line of storms with these characteristics. If we have a low pressure system which really engages with the jet, we get what we call explosive cyclogenesis as the storm really, really rapidly deepens and intensifies. And we can see some very, very strong winds in a swath, affecting the worst areas. And it's really critical understanding what the precise track is going to be and whereabouts is going to be affected. And in this particular case, it was the far bottom of Cornwall. But of course, a much, the really kind of notorious example, if you like, is October 1987. In the southeast of England. But, we are in the firing line of storms like this.
Yeah, and I think when you have something with Goretti, it was suspected to be a sting jet with Goretti, and it's such a narrow band of where it's going to affect. But also, I guess, with Cornwall as well, it's quite a narrow land mass as well. So I remember there being some uncertainty in where the narrowest band of the strongest winds were going to move across the land exactly. So,
I mean, the other thing to say is, of course, that around coastal areas tend to experience the strongest winds. So if we look at the wind climatology for the UK, places like Cornwall are prone to very strong winds just because being on the coast, out to sea, there is no drag from the land and the hills and so on. So
less friction is
less friction, and in fact the highest gust speed on record for England used to be right down at Gwenat Head, which is really near Land's End. More recently, it's actually moved to the Needles on the Isle of Wight. But again, these are both very exposed coastal locations. Yeah,
so often they're not representative of what's happening inland, are they? But still, for Cornwall, such a coastal region, to be honest, predominantly there were huge impacts, and for the Scilly Isles the Isles of Scilly
dangerous waves as well, dangerous conditions on the coast too.
Yes, and it's taken quite a while to, I think, repair all the damage from Goretti as well. After, like you were saying, with the antecedent conditions of the ground levels, how saturated the ground is, similar in that when you see a few more windy weather coming through, it's like, well, there's been damage to wind in these areas, so these areas were more sensitive to less impactful, not named storms, but windier spells as well for at least a few weeks after that.
Yeah, I mean, we do see that. If you have storms one after another arriving rapidly in succession, the clear up from one storm and maybe trying to get power back to people is then exacerbated and hampered by the fact that there's another storm coming. And of course, often these most severe storms happening at at a time of year where you can get storms in the sequence in this way. So that can make it particularly challenging for people if if they've lost power for a prolonged period of time. And of course, the age in which we live, we're all dependent on electricity, perhaps more than we used to be in the past.
Yeah, very good point. And then we've had the most recent named storm was Chandra, which affected places very close to Exeter. I know a number of Met Office employees were affected by the flooding in Storm Chandra.
There was widespread flooding in the southwest of England, actually a bit more widely. By this time, I think we're starting to see larger river catchments really responding as well. But certainly down in the Exeter area, some of these catchments on the south coast, the River Exe, just to the east of us, the River Otter, the River Axe, we saw some quite severe flooding, unfortunately affecting properties.
Yeah.
What I would say is it's important to put this flooding into context, that, you know, we are talking about perhaps dozens of properties flooded, but we are not talking about thousands of properties flooded, as was seen in the scale of the floods of summer 2007.
Yeah.
But obviously that is, you know, if you are one of the residents who's been affected by flooding, that's clearly no consolation.
No, it isn't at all. But yeah, it was still relatively localised in some ways. So yeah, we did have some major, some big storms that came through. We've talked a little bit about that nice cold weather, the clear weather we had at the beginning of January, but that also brought some pretty exceptional snow. Like, snow is becoming less of a thing with climate change. We see less of these significant snow events, but we saw some really high depths of snow, particularly across the Grampians region in particular.
We did. Yeah.
This is here we've got the 9th to the 6th of January, so just after the 6th of January.
6th of January.
Excuse me.
6th of January.
The depths are at 9.
At 9, yeah.
Excuse me.
Yeah.
But they built up through the New Year period, and so some of the highest. What's the highest number we've got on here? Is that 52 centimetres.
Yeah.
And that's quite exceptional compared to recent years.
Yeah, I mean, so our climate is warming.
Yeah.
And obviously that means that we are generally seeing a decline in the number of snow events across the UK. But the variability of our weather means that we still do see from time to time significant lying snow in the UK. So examples would be 2013, 2018, more recently I think 2021. Would be examples where we've seen some fairly significant snow across northern parts of the UK. And of course, this part of the UK is, you know, furthest north and east. This is most prone to snow. So I would say that depths of perhaps 30 centimetres or so are not really especially unusual, although of course they cause significant impacts. But when we get day after day of snow accumulating from, say, snow showers in a northerly flow, and it's just fairly relentless, with depths of 50 centimetres building up. These are, that sort of depth is, for this area, kind of about the most significant since December 2010. So December 2010 was really exceptional for the UK. It was the coldest December on record for the UK. That's that temperature series goes back to 1884. Yeah. I would say that's all the more exceptional, bearing in mind that our climate is warming. So it has already warmed quite considerably by the time December 2010 happened. But you know, these depths are really, really significant. And of course, they cause large impacts. So in particular, things like school closures. If schools are closed for a week, problems with transport, people being able to get around, problems with isolated communities and so on. Yeah. So this was undoubtedly, you know, this was an unusual. These depths of 50 centimetres are really quite unusual. Yeah,
and then when it starts to get warmer as well, I guess there's also the snow melt as well that's considered from all of this.
Actually, that is something, I mean, you know, this is one example of where we might argue that we are actually seeing less events of that particular type than we used to because of climate change, is snow melt events. So in the UK, one of the most severe snow melt events occurred in March 1947, after the very, very severe February 1947, which is really, I think, the most, you know, severe snowy spell, or very, very widespread
across the UK,
very large depths across the UK, some very devastating flooding in large areas as a result of that melting, and that doesn't happen so much now.
No, because we don't. But I think because the UK is already in that kind of marginal temperature all through the winter of it being cold enough for it to snow in enough places. Snow situations are always so marginal.
But I suppose what it does illustrate, though, is that, you know, there is the potential for impactful weather from snow still to happen, despite the fact that our climate is warming. So we still need to be prepared.
Yeah, you can't. Yeah, things become more likely, but it doesn't mean you're not going to get cold winters at all. But they become less.
Indeed,
likely.
You might argue that it's more difficult to think about how you deal with events that are very infrequent, as opposed to something that was perhaps considered rather more normal. So snow is a really good example, actually, that you know, perhaps in the 1980s, fairly widespread snow across, for example, I mean, so we're talking about Scotland here, but I was thinking more in the context of central England, that we might, it's not particularly unusual to see a week or a couple of weeks of snow, lying snow in the winter in the historical record, looking at that period. Now that is much more unusual, although it can still happen. So does that make it more impactful now than it did in the past, because we're less used to events of that type?
Yeah, it's often if something if it's been suddenly, often it's the first cold snap that can catch people more off guard, is when you're not in the mindset of it. And I guess that's similar if it's something that doesn't really happen very often, or only really happens like once in your lifetime. Then you're not going to be able to behave appropriately, or you know exactly what to do, or you'll be caught more unawares. Oh, really fascinating. It has been an interesting winter then, definitely.
Yes,
thank you for sharing all of those details and going over everything. We haven't gone over absolutely everything. It was also a bit of a dull winter and a relatively mild one as well. But you can find all the details in the press release and on our website as well. Thank you very much for joining us at home. Thank you for watching. If you've got any comments or feedback, make sure you leave them in the comments box below. And make sure you share this video with anyone else you think might be interested. Don't forget to subscribe if you haven't already. But yes, join me in giving thanks to Mike once again for joining us and sharing so much information, not only on this winter, but on all the winters that came before. You've amazed me with all of your knowledge. Thank you very much. And we'll see you again soon. Bye-bye.